3.6 and we have 2.6.
Yeah.
Because we're on Unit 2, I just haven't edited all the slides to change it to say 2. It used to be Unit 3, so that's why it says 3. But all your notes should be edited to say 2. Yeah? Yeah, it's just not, I'm using an old version. Time. You have a sheet? Okay. What we're working on is something called factoring. It's like the reverse of what we were just working on. What we were doing before is we were multiplying things in. Now we're going to start taking things out. So quick review of what we've done. We've done a monomial by a polynomial. You guys did really well on your test. All of us. So yeah, as a collective group, we did great.
I got 37.
So that is multiplying this in distribution property. You guys are really strong at this. Then we did it, we moved on and we did a binomial by a binomial, which resulted in a trinomial. That wasn't every case. Sometimes it formed a binomial. These ones did trinomial. So what did we use? Do binomial? Yeah, FOIL. So your answer should be this when you use FOIL. The next one, if you use FOIL, should be that's either you could call it FOIL. Some of you actually were using the area diagrams, and some of you were even drawing out the tiles. Whatever way you did to multiply these things is beautiful. It's working. Sometimes our binomials by binomials formed a binomial, and that's a special case which we'll look in even further. It results when you have a positive and a negative 5 that are the exact same, because they cancel each other out. So when this term is equal to that term, the one in front of the x's, and then the second terms were opposites. We had a plus and a negative 5. They cancel each other out. So we have x squared minus 25. And your resulting thing is something called perfect square binomial. So what we have here is something that could be square rooted and give you a whole number. What we have here is something else that could be square rooted. Except it's a negative, so it can actually work out, right? You can't square root a negative. But you could square root the 25. Upcoming, guys, like I said, we're factoring. So now we're going to do things in reverse. You're going to have answers like this, and you're going to have to turn them into that. Yeah. And we're going to start off exactly where we started off before, with monomials. So we're going to start off by just taking one constant out. That's called your greatest common factor. A factor is something you're dividing out. So factors of 6 are 2 and 3. Because 2 and 3 both divide into 6. Our goal is going to be looking for the greatest common factor. So we look down here. Factoring by removing, we copy this out. By removing a common factor. So what you need to do is look at all the terms. That's a term, and that's a term. And you need to find things that are in common that divide into both of them. And it has to be the greatest thing that divides into both of them. So what's something that divides into both terms? 2 and x. X divides into both of them. And you're left with x plus 5. So what we did is we looked at our terms. Our first term was 2x. Our second term was 2x squared, and our second term was 10x. Then you're going to look at the coefficients. What are the coefficients? What are the coefficients of this term and this term? 2 and 10. You want to find the largest number that divides into both 2 and 10. 2. That's where we got this 2 down here. And then you want to find the largest thing that divides into x squared and x. Just one x. That makes sense. Does that make sense, Kendall? Clear it up a little bit? No? The way you can check your answer is if you took that and applied it in. If you distributed that back in, you should get your original question. What's 10 divided by 2? And what's x divided by x? 1. X divided by x, they both go away, so it's just 1 left, which gave us just plus 5. We got just our x because 2 divided by 2 is 1, and x squared divided by x is x. Yeah. It's dividing it out. Yeah. You're not subtracting it, you're dividing it out. But yeah, it's the same idea, right? It's reverse of what we did before. So these first ones, greatest common factor, are the first thing you're going to do on every question because it'll make life way easier. When we get to questions like this, it's way harder to factor those back out. Okay, let's look at this one. Factoring a trinomial and factoring a difference of squares. So we should be able to turn this in the future back into this. So it'll be x plus 1 and x plus 3. It's the same thing, it's just reversing it. In the future, I'm going to show you guys how to do that. That's a whole other lesson. Right now, what we're super concerned with is our greatest common factors. Our monomials by our binomials, or monomials by trinomials. This one, the result should be this. Yeah. You didn't do that, right? Why did you do that? Mine's wrong. It's way easier, right? And this one is difference of squares. That's why I said it has a special name. It is just x plus 5 and x minus 5. And for those of you guys who can't see at the bottom, all I'm doing is rewriting it out. So if you look at your notes, it's going to be the exact same. No, I'm looking back at the top. So, no, you get just 2. X squared minus 25 was created by this question up here.
I didn't know anything was
Bigger? I don't know how to zoom back in. Which one are you looking for? Extending the page.
Press the back thing on the micro. Circle. Yeah.
No, it's a racing pen. Okay, so let's look at some examples, guys. Greatest common factor. You're going to see this throughout the entire unit. So, greatest common factor. You want the greatest thing that divides into both things you're given. Yes, Jared? Yeah, so let's start off. This is one term, second term. You're going to look at the constants, 12 and 15. What's the greatest number that divides into both 12 and 15, Jared? 3. What's the next term that you see? Yeah, AB. So what's the greatest thing that divides into the A to the A squared? Just 1A. And for the B's, just 1B. 3AB would be your greatest common factor. You can't divide out B squared because there's only 1B here. So you're limited. Let's take a look at this one. Greatest thing that divides into 18 to negative 24? That's a good question. Is it positive 6 or is it negative 6? Can you take negative 6 on 18?
No.
Why not?
Well, isn't negative times a negative?
Yeah. So you just take a negative out of that, and it would leave you with a negative number. So the rule of thumb for dividing out your negatives for your greatest common factor, only take out a negative if they're both negative. The 18 isn't negative, so don't take out a negative. Leave it as positive. So what's your greatest common factor? For the constants? Positive 6, because there's no negative in front of the 18. So don't take out a negative. Yes, I just said that. So you can take a negative out. The rule of thumb is not to unless they're both negative. Yes, Morris?
So wouldn't it, you want to take out 6, basically 6 is greater than negative 6?
Yeah, that's a great way to look at it. Except if they're both negatives, you would want to take out negative 6 instead of positive 6. So greatest number. And don't worry about the negative side. Because you're right, 6 is larger than negative 6. Yeah. Hey, you have x to the power 4 and x to the power 3. So what can we take out? 1x? X cubed. Yeah. You take out the largest exponent you can. So you'd be left with 1x here and no x's in that one. And y, how many do we take out? 2. So if you follow the same rule, you take out the largest number possible. So we see that there's 2y there, so we took out 2y. There's 5 over here. But if we took out 5, we wouldn't have any to take away. We'd run out over here. Take the smallest one out that you can.
What if you had like a 2 and like a 4, and the smallest one would be 2?
Yeah.
Okay, that doesn't work, but like what if you had the numbers? And then, so it's always the smallest one?
Yeah.
Oh.
When it comes to your variables, it's always just the smallest exponent. Yeah. If that's the best way to look at it, that's the best way to look at it. It is?
Radical.
Radical, man. You're a disaster. Okay. How was it? Yes, it's just nuts. Now we have 3 terms. So you have to look at all 3. What's the largest coefficient we can take out all 3? Negative 10. Because all 3 have a negative, so take out negative 10. What's the largest a we can take out? A squared. And the largest b we can take out? No, just 1. There's only 1 b in this first one.
Really easy.
That's
Looks difficult, but it's easy.
That's literally all we're doing today. Dawson, it's not rocket science. Yeah. Yeah. Question, Dawson. So that's going to take some practice. So what you're going to have to do, I'm going to write it over here on the board. So we're going to take negative 40, negative 20, and negative 10. Because they're all negatives, we know we're going to want to take out a negative. So our answer is going to be negative something. What you want to do is you want to write out all the numbers that divide into these things. So, what divides in 40? You got 40, 20, 5,
2, 4, and 1. Oh, you gotta put the
missing some.
8.
8. Right? I got 8. It's on the bottom.
Gotta put the negatives in there too.
We've already taken a negative. Yeah, but you're right, Matthew. It's going to be a negative, right? And I'll do the same thing for 20. So you can divide out 20, or 5, or 4, or 1, or 2, or 10.
We got 10.
And over here, 10.
5, 2, 2, 3.
You want to look at, not you. Stop. Thus, you want to look at these lists you created and find the largest number that's in all the lists. So the largest number is 10. And that's why we took out negative 10. Adios. For B, why did we take out a positive? Because this one wasn't a negative. If all the terms are negative, take out a negative. If not all the terms are negative, just leave it alone. Only take out a positive number.
So for the 18.
Yeah.
In skills, nothing's should be involved.
It should be, you'll look at it and you think it's like the easiest thing in the world when we're doing it, and then you'll practice it and you'll be like, how am I constantly getting like one number off, right? Like it'll be so minor. Like this question, you'll probably see people take 5 out because there's multiple, that 5 is in common in all of them. Or you'll see someone take just a single A out or a B squared out and they miss that there's a B here. Right? So it's all about fine details in this unit.
It's so easy. It should be harder.
Now we're going to move on. So before, it was just asking you for the greatest common factor. Now you're going to actually factor each polynomial. You guys don't have this? Very back. Perfect.
Very back.
Oh, you already did it.
Okay, that's fine. We'll talk about it. Okay. So your note packages are a little messed up, so just write out whatever you need to write out so it makes sense. Okay, Josh? Just write out whatever you need. When you're actually factoring the polynomial, you need to leave a statement of multiplication. So before we were just finding the greatest common factor, now we need the greatest common factor and the remainder. So what's the greatest common factor of this first one? What's the largest number that goes into 20 and 6? 2. How many x's can we take out? Michael, we just discussed this. It's not in your notes. So you have to put that.
It's on here, except for the answers.
Yeah, that's fine. We're talking about it. Can you take out any x's?
Yes.
No. Because there's no x here.
Oh, actually.
So you can't take out an x. So your answer is just 2, and then what are you left with? 20 divided by 2 is... We didn't take any x's out. 6 divided by 2 is... Next one. What's the largest number that divides into 16 and 4? X squared. Because what's the smallest number of x squared? 2. Right here. So what are we left with? 16 divided by 4 is? Don't just square out answers, guys, because people who aren't as far ahead as some others. Just joke. It'll be x squared, yeah, because x to the power 4 divided by x squared is...
That's really what I read.
4 divided by 4 is 1. X squared divided by x squared is... Michael? Yep.
Why do you divide?
I'm dividing because it's like I'm dividing that out. So that if I multiplied it back in, I would get that answer.
Oh, yeah.
X squared divided by x squared is just 1. So it's plus 1 on the end. And C, what's the largest number that divides into 12, 6, and 15?
3.
Perfect. Oh, sorry, how many P's can we take out? That's 4 P squared minus 2P plus 5. Yes, Eric.
Oh, it has to put a Y in it. So it doesn't
That was right.
square across.
Yeah, just change it to this question if you need to. Any questions about these? Perfect. You guys do have this slide. This is your last one. Right? Oh, yeah, you say, why do I understand this? Why is this? Guys, the important part about this being easy is that you absolutely nail it. This is like, if you look back to elementary school and addition and subtraction, and you have to have that perfectly memorized to be able to do math now. To do the next week worth of factoring, this stuff has to be automatic and really, really easy. So the practice that we're doing now is important. You can't just accept the fact that you're good and not do it. So, what's the greatest number you can take out of 10 and 8? Jared? 2. How many A's can we take out, Kendall? 1. How many B's can we take out, Taylor? 2. Lowest exponent. And if it doesn't exist, you can't take anything out. So if there was a C here, you couldn't take any C's out, right? Because there wouldn't be a C there. What are we left with? That's going to be the hard part. Figuring out what you're left with is hard. Joe, what are we left with for the first one?
Would it be
5? Your name's not Joe.
5a squared?
5a squared.
And then
Yep. And then Michael will give us the second one. What are we left with, Michael?
4.
You got it.
yes.
Okay. What is a good question? So let's look at the first one. This that 5x squared comes from that divided by that. So if we were to write that out, 10 a3 b squared, and we were to divide it by 2ab squared. The 5 divided by the 2, or the 10 divided by the 2 gives you 5. The a cubed divided by the a gives you a squared. And the b squared divided by the b squared just leaves you with 1. Does that make more sense now, Nelson? And that's your first term. Then we still have to add because it came from that addition right there. And then you do the same thing. That one divided by that. Michael. Yeah.
Oh, wow.
That's why I'm sitting here saying you gotta practice this stuff. It's gonna get way harder.
I was like so hyped, like I get this for once.
Yeah.
Well,
The hype is pretty low.
Matthew. Okay. This is the last one, guys.
Joe, calm down.
Joe, take a breathe.
Okay, fine.
This is the last one, guys. What's the largest number that divides it to 25, 20, and 30, Aaron? 5. How many X's can we take out, Dawson S? Just 1. How many Y's can we take out, Reese? 2. How many Z's can we take out, Carter? 2, yeah. The hard part is usually figuring out what's left over. So we took a 5 out from this first term, that leaves us with 5. We took 1 x out, there was only 1 x to begin with, so those are gone. We took out 2 y's, there was only 2 y's to begin with, so they're gone. We took out 2 z's, 1 z. There was 3 z's to begin with. Minus. The minus sign comes from right there. 20 divided by 5 gives you what, Matthew? 4. We took out 1x, so we're left with an x. We took out 2 of the 4 y's, so we're left with 2. And we took out all the z's. So the z's are gone on that one. Your third term, Boris. 30, we divided by 5. What are we left with?
6.
You got it. We took out 1x from the 4. How many left with, Murph?
2.
How many x's?
2.
We took out 1.
3.
There was 4. 3 left.
1 minus 1.
How many y's are left, Michael?
What?
We took out 2. None left. How many z's are left, Josh?
There is 2 cents.
3 z's. We started with 5. We took away 2. That's your final answer.
Yes.
Pretty easy.
Pretty easy. Any questions about it? Beautiful.